have my colleague Deven Dhulia joining us. Thank you very much, Deven, for making some time out of your day. Yeah, so why don't you start by giving a brief introduction for the audience?
Okay. Hi, everyone. My name is Deven Dhulia. I live in San Francisco. I'm a software engineer by trade into database management technology. I've had about 25 to 30 years of experience in software engineering, in data warehouse consulting, as well as in executive management as director of enterprise data management for companies like HP and Salesforce, and also as an enterprise data architect. Now I'm the training lead for data strategy professionals. So that's my background, and I'm excited today to talk about data architecture, answer a few questions, and give you some real world scenarios and examples from my own experience and expertise over the years.
Yeah, fantastic. Well, again, thank you for joining us. Devin's a CDMP master, so proven that he understands this stuff by attaining the highest score on the fundamentals and the two specialist exams. Okay, so my first question for you, Devin, how do you think about the scope and boundaries of data architecture relative to application and technology architecture? As we mentioned in the intro, this chapter is pretty broad. So, how does data architecture kind of fit into overall enterprise architecture? And how do you keep the boundaries of data architecture from eroding over time?
Okay, that's a good question. So the classic enterprise architecture framework that was introduced by TOGAF and then also socialized by Gartner and Dharma and other organizations which introduce architecture frameworks is of these four architecture domains of business, data, application, and technology architectures. Business architecture is essentially where you identify your value streams and business capabilities and information objects, the policies for the organization, as well as the key initiatives, etc., which will work together, provide value for the business, and achieve these desired business outcomes. So data architecture then takes these business outcomes and looks at the data landscape, your applications, your data sets, your platforms, and builds this picture of the current capabilities that you have and builds a future state architecture, which would include the enterprise data model, which includes attributes, entities and their attributes, relationships, and then the domains from which entity values can come from, and then creates these data flow designs for how data moves from the system across applications and systems all the way within the enterprise ecosystem. And then it also goes ahead and creates these reference architectures for key data management applications like master data management, MDM, metadata management, data quality management, and also builds the star schemas as well as the dimension models for analytical applications like data warehouses and data marts. So that's the scope of the enterprise data architecture. So essentially introducing all of these concepts at a high level at this point at the enterprise level. Then application architecture is where software engineering or data engineering or application engineering comes in play. They build the software modules as well as the key software features and the cloud services that are required to enable, which take this data and enable the key business functionality to reach desired business outcomes. So that's the scope of application architecture. And then technology architecture, what that does is essentially takes these application services that have been created, registers them with cloud service providers like Azure and AWS and GCP, and allows them to and creates these products which can then be sold as software as a service, platform as a service, iPaaS, as well as integration as a service, etc. So all of these mesh together to make the enterprise cohesive whole to be able to identify from the strategic objectives and then go all the way to creating these desired business outcomes. Does that make sense?
To me, it does. Yeah, so Elise asks, is it a continuum or are they discrete disciplines?
Well, it's a continuum in the sense like the architect, the business object, the business outcomes, and the desired value stream business capabilities from business architecture are taken by data architecture to say, okay, to achieve these business capabilities, what data do I need? What application do I need? What data model do I need? And then once that data model has been created, this is taken by the application architecture to say, well, in order to realize these capabilities and this data model, which application services do I need to build? And then technology, of course, takes all of these application services and registers them with cloud service providers, for example, in a cloud architecture. So it is a continuum, I would say. And they're not discrete aside. There's handoffs. Enterprise architects could wear multiple hats: enterprise data architect, enterprise application architect, and enterprise business architect. For example, in my experience, I'm both a business architect as well as an enterprise data architect in my profession.
Very cool. Okay. Yeah, thanks, Elise, for that question. So Solomon asked, like, he tends to think of data architecture as strategic and application architecture as tactical. So is that kind of a good way to differentiate between them?
I would say yes and no. So at the enterprise data model level, that's definitely strategic. You build a data model to integrate all of the business functions and the data from across all of these business functions, right? And then the application architecture will create specific applications like a CRM application for sales and marketing and customer service, or an ERP application for revenue and finance off of this enterprise data model. But there is a tactical component of data architecture here as well, because it will create these application or domain specific data models to enable these applications. So yes, whereas the application modules, etc., are built tactically, data models also built tactically to support these applications, right?
Okay. And then second part of the question is, can you give a scenario to elaborate on the difference between the four?
A scenario to elaborate.
Yeah, feel free to pass on this one because I think of this as being a kind of difficult question.
Well, no, I mean, the scenario is like take any kind of enterprise, right? If you do digital transformation, and digital transformation is a big thing these days, which
Hmm.
a lot of like enterprises are moving their legacy applications into cloud architecture, creating this technology foundation, creating these data lake houses, whereas earlier there used to be data lakes and data warehouses only. Now there's this concept of data lake houses in a medallion architecture. And then they're building these key applications, creating these databases like vector databases and knowledge graph to support large language models for AI. So within an enterprise requires this kind of digital transformation requires enterprise architecture. Enterprise architecture is a way that you can determine for sure and prove that the business capabilities that you are standing up, that you require to reach your business outcomes have been delivered by the enterprise through business data, application, and technology services. So any digital transformation will mesh all of these together to create that technology foundation and the business application transformation as well.
Awesome. That was really thorough. Great job with that. Cool. Okay, so Solomon, hopefully that answered your questions. All right. When you're setting up a modern data platform, how do you decide between various options, such as a centralized platform, which could be a data warehouse or a data lake, or decentralized, so something more like a data mesh? And then what trade-offs are you considering in making that choice?
Right. So the first thing to consider is when answering this question is what services are you providing by a centralized architecture and what service you're providing by decentralizing, right?
Mm,
So centralized data architectures are for data lakes and data warehouses and data lake houses. And each one of these has a different function. They support different kinds of data volumes, different kinds of workloads, as well as different kinds of data models within
mhm,
them. So data lake, for example, is going to take your input data from streaming data for real-time historic data on enterprise applications and loads it into this commodity server-based database and keeps the data in this raw form. There's very little transformation that happens over this data. And so that data lake can then be used by business users to do exploratory analysis and deep analytics and lend itself to feed AI models as well. Data lakehouses can support both structured, unstructured, and semi-structured data. Data warehouses, on the other hand, are primarily focused on structured data, and these are used for answering the long-term high-volume queries for supporting trending and forecasting and descriptive analytics, etc. These are where the data is stored in dimensional models and star schemas or snowflake schemas. This is also a way of centralizing all your data into a single data warehouse. Data lakehouses now merge these two data lakes and data lakehouses into a single platform, which is called a lakehouse. And in the lakehouse can support all structured, semi-structured, as well as unstructured data. But the beauty of this one is that there is a single layer for both. It can support both streaming data as well as real-time data and ingest the data into what's called the bronze layer. And through a process of cleaning, transformation, standardization, and data modeling through the silver layer and the bronze layer, create this analytics ready data for calculated insights for deep advanced analytics using supervised learning and unsupervised learning and reinforcement learning, and also as input to your LLMs for AI. Essentially, these are the three kinds of architecture for centralized architecture. So data mesh. The data mesh is more a framework rather than an architecture as such. It can be basically a framework which can be on top of both centralized data sets or decentralized data sets in different applications. The bottom line is what data mesh provides is a domain-specific view of your data, and it treats data as products. So every domain will have its own technology infrastructure, its own data model, and support its own data products. So for example, sales domain would have orders and customers as products. The marketing domain would have data as a product. The finance domain will have AR and AP modules as products, and revenue would have collections and invoices, for example. So all of these are decentralized data sets, which can then be monetized in exchange between internal and external stakeholders. Data mesh really more of a framework, and it can be on both centralized and it's more, I would say, not decentralized as such, but really domain-specific architecture.
Yes. Okay. Very comprehensive answer. Very well explained, Devin Hart, says someone in the chat. So definitely agree with that. All right. So next question. Can you walk through the layers of a reference data architecture? So for example, ingestion, storage, processing, semantic layer development, and consumption, and explain how you would enforce separation of concerns across those layers.
Okay, so that's a mouthful. That's a lot. I shared a link with you, Nicole.
Yes,
Mind presenting that? Okay.
totally. Okay, perfect.
So take a minute to look at this. I published this a little while ago, but essentially the various layers, and it's nowhere near as beautifully in these perfect swim lanes as you see over here. But this is a reference architecture, which says it can be a hodgepodge of structured data going directly into a BI, DI layer or skipping some of these layers in between. But essentially what happens is you'd have these data sources. Data is sourced from various different sources. That could be your structured data, which includes your tables, relational tables, etc. Your semi-structured data, your JSON, XML, HTML, etc. And your unstructured data, which is coming from your videos and text, social media, images and files. So all this data is then ingested into what is called the staging layer. The ingestion mechanism could be messaging, which is for really for real-time small volumes of data, point-to-point, API gateways, pub-sub architectures. These are all request response, which is a real-time synchronization, etc. This is one way of ingesting data. It's really used for application integration. And then there's data integration. Data integration is things like takes larger volumes of data in batches and uses technologies like ETL, extract, transformation, load, and data batching and CDC to load this data from operational applications to analytical applications, for example. But it also can be done, batch load can also be done to initially load the operational applications too. Then there's streaming data. This is your Kafka streams, etc., where this continuous flow of, say, social media, more like semi-structured and unstructured data that can be pulled. So that's data ingestion. And then orchestration is how you orchestrate the data workflows. Data preparation is the next phase. For example, you prepare the data to load it into the application. So this will be data enriching with third-party data sources, standardization of data so that it has the same look and feel, data correction, so remediation of any anomalies in the data, preventing of duplicates, entity generation when you have multiple duplicates, when you merge them together, then basically you'll create this single entity. Data augmentation, this is like AI-enabled services to augment the data and harmonization of data across multiple sources and consolidation. All of these data preparation activities happen. Then finally, you load this data into your application systems. And most often, this is the first layer, which is your data processing, operational processing. This could be your CPQ, CLM, CRM, ERP applications, supply chain management, HCM, human capital management, revenue management, product management. These are where the heavy duty day-to-day business operation happen. And then this data is using integration processes. Again, these could be batch, streaming, orchestration, is loaded into what is the analytical layer, right? But before you do that, there is some levels of master data management and relationship management and hierarchy management that is done to integrate this data to create what are those then called these conformed dimensions in the data warehouse layer. Then you see, after all this data management has been done and this data has been integrated, you load it into your data warehouses and data marts. This could be underlying storage, could be file storage or block storage, or now with NoSQL database, it could be object storage to support document databases and key value stores, etc. And once that is done, you can run your business intelligence, data intelligence, artificial intelligence applications for visualization, creating OLAP cubes, creating these SQL query interfaces, doing operational analytics as well as data exploration and diagnostics, and then the various different machine learning kind of queries as well. As you see, the application services, integration platforms, data management services, data management platforms, and then BI and DI application. But what is the thread that underlying all of this that keeps it all together and ensures that there's good data lineage, there's high quality data, metadata definition is the data governance layer. So data governance is across this entire life cycle. It creates data governance programs, create the data governance policies, address the data privacy regulations, data stewardship processes, data handling standards and all. So data governance is applied on every particular stage of this data life cycle.
Very good. I think they should put this in the Diembach V3. It makes a lot more sense than some of those framework diagrams I have in the first chapter. So I did have a question around this, specifically in data preparation. Is entity generation similar or the same as entity resolution? What's entailed in this step?
So entity resolution is typically when in master data management, when you have duplicates in the application. And so you have to merge all of these and then create this entity, resolve these duplicate entities across applications or within the same application system, and then create this master data management global entity. That's entity resolution, right? So you could have John Smith, John K. Smith, and John Kenneth Smith. There are three entities. Now, John K. Smith and John Kenneth Smith are the same entity, and John Smith is somebody else. So you will resolve those entities and identify these as having a common entity identifier. So there'll be two different entity IDs, one for John Smith and one for the merged value of John K. Smith. Entity generation is initially when the data is brought in and loaded into your CRM applications or your ERP application. You first stamp with an entity identifier, your entity ID, your customer ID, your product ID. So that's what entity generation is.
Okay, got it. So this is like your initial data preparation step, as you say. So yeah, so Elise was asking, could that be creating like a hex ID from attributes? So I guess I'm not super familiar with that specific term, but yeah, it is like creating the ID, whether it's a surrogate ID or whatever process your organization chooses.
Whichever algorithm you want to use to create these unique identifiers, that
Hmm.
and the system generated, or they can be using hex algorithms, etc. I mean,
Okay, great. Hopefully that answers your question, Elise. So let's go to our next question here. How do you architect for both operational, so an OLTP, and analytical, an OLAP workload without duplicating everything? And then when would you choose to deliberately embrace duplication?
OLTP is online transaction processing and OLAP is online analytical processing workloads. They both serve different purposes. And so, therefore, there's the underlying data models, the way the data is created and managed in these is different for OLTP and OLAP applications. Is transactional data leveraged in your operational application like CRM, ERP, CLM, etc.? This is primarily low volume, but it is highly relational. There's an entity relational diagram, for example, which is underlying these, and it is loaded in small batches or in real-time messaging, etc. It is persisted in highly normalized third normal form relational databases, and it is used to query small batches of data or query a processor update or delete small volumes of data, like a specific row, for example, in your transaction application, right? OLAP workloads, on the other hand, are used for large volumes of data, which is stored in dimensional databases, where you have your facts and dimensions and loaded into these star schemas or snowflake schemas. And these essentially used for processing. So the data in these OLAP databases is really the historic version of these transactions from these OLTP databases. Whereas OLTP application will have probably a few days of data at the most, but it will mostly be very current. OLAP databases have a large amount of historic data as well as the current data. It'll have like based on your nightly loads, or it'll have daily snapshots of your data, but going all the way back to 3 to 5 years, depending on what your retention policy is. And so the kind of queries that you can run are like on these high volume of data for doing things like trending and forecasting and to do what if scenarios and the OLAP and diagnostics and exploration, etc. And then staying with structured data only. OLTP data is extracted, stored in a staging area. So when you talk about replication, when will this data be replicated? What were the scenarios of replicating this? So typically, OLTP data sets will be replicated in what is called a staging area. The staging area is where data preparation is done to make it ready for loading into the data warehouse. So those are considered to be copies of the transaction processing data sets. And the reason to do that is because you don't want to have these high running, like complex queries, which are extracting and transforming this data to be running on the production databases themselves. So you quickly offload that transaction data into a staging area. That's where you do your cleansing, standardization, normalization. So yes, there's a copy, but there's a reason for why we want to create this copy. And then for OLAP databases, essentially you have these data warehouse which could contain multiple facts across conformed dimensions, which are supporting multiple subject areas, your finance domain, your marketing domain, your sales domain. But then each of these business functions may require the specific set of facts only pertaining to their needs across these conformed dimensions. So that's when you create these data marts. Data marts are generally copies of the data warehouse because they copy the same conformed dimensions and copy specific facts from the enterprise data warehouse, which are pertaining to that subject area. They may not always be at the lowest level of detail. Often data marts are aggregated or summarized. But yes, you could say that these are copies. That's when I would use replication. When I have to make domain specific queries, I would create subject data marts. But staging areas are non negotiable.
Okay, awesome. So, looking ahead 3 to 5 years, which emerging capabilities do you believe will most materially change data architecture? And how do you think we should accommodate those changes now?
Okay. So 5 years, the world could be completely different in 3 to 5 years, given the kind of advances that are happening in AI. Right now, we are just focused on ANI, which is narrow AI, which does
Mm,
specific things. Those
mhm,
in 5 years be general AI. But our job as data architects, everybody in this group should remember this, is no matter what kind of data, what kind of AI advances are taking place, our job as data architects is to create clean, correlated, interrelated data, which is of like high data lineage from targets to source, which is standardized and can be used across any AI model on any AI model, and should be able to support all types of data, all
mm,
volumes of data, all variety of data, and so on. So one of the things that advances that I see is yes, there are going to be changes in the way that we ingest data. You have NL pipelines and textual and multimodal data. That is unstructured data, which is 90% of the data that we have today, and we haven't even tapped into it. But one of the advances I see is how unstructured data is
mm.
going to be integrated with structured data to create the 360-degree view. For example, in a patient, payer, provider kind of model in a healthcare organization, you will have your structured master data and metadata for patients and all these entities, but you'll also have all this unstructured data about them, which you can then integrate and create this 360 view of a patient. So you can do everything from the single platform, do a medical diagnosis all the way to paying for the treatment as well.
Awesome. Thank you very much. And so we did have another question, Devin, around the framework that you shared. If I'm interpreting this question correctly, it's asking, should the domains within the framework, is that solely the responsibility of the data architects, or do the other enterprise architecture domains play a role, like technology and application?
Absolutely. Application architects will create that layer of data operation, which we have, like your CRM, ERP applications. Technology architects will create the infrastructure, the various different platforms to support both operational as well as analytical applications.
Great. Okay. And then this is probably just like a basic definitional question, but can you explain a little bit about what a data mart is? And then I know it's a little bit of a tricky concept, but also briefly like what a data mesh platform is.
Okay, so data marts are essentially offshoots of data warehouses. So data warehouses at the enterprise scale will have multiple fact tables and conform dimension. Conform dimension means these dimensions look the same across every fact table that you have, right? So this supports the entire enterprise. Now, there could be some sub business functions which don't care to have all of these extra dimensions or these multiple facts. Marketing, for example, has no need to look at the financial fact tables and dimensions associated with that. So they could ask for a marketing specific data mart, which will take all the fact tables which are associated just for marketing, for product marketing, for digital marketing, and the conformed dimensions that are applicable to them, and then create this offshoot, which is a separate database, which has just the specific fact tables for marketing function and the conformed dimension for the marketing function. These could be then be aggregated and summarized, and you can add more data to them as well, extend these tables, and that will become your marketing data mart, for example. And data
Mhm.
mesh, as I said, is not really a platform, it's more of a framework. And it can be done on both decentralized as well as centralized infrastructure ecosystems. It looks at data as a product, and domains own specific data products. For example, as I said, marketing domain will own the product and the product data and monetize it as a product. The marketing domain will have the technology. So there will not be a centralized IT team. There will be decentralized organization
Mhm.
supporting each of the domains. They will create the infrastructure, the platforms, the data models, load this data, cleanse it, create the master data sets for this data as well, and share it as a product, monetized product with the internal, external stakeholders. What is the glue between all of these is the metadata layer. If you don't have a rich, unified metadata layer, then you can have as many domains as you want. It's going to become like data silos, and nobody's going to be able to use them or integrate them.
Okay, hopefully that answered your question. So, thank you guys all so much for coming. Deven, it was awesome getting to hear your wisdom on data architecture. I hope everybody has a great rest of your day, and hopefully, we'll see you next month for another session like this one.
Great.
All
Thanks a
right.
lot,
Thank
everyone.
you again. Bye, everyone.